Consider a merry-go-round that makes one full rotation in 2 seconds. What's the angular velocity of the merry-go-round? What's the tangential velocity of the child? And what's the centripetal acceleration of the child? Just by knowing the time it takes for one rotation and the distance the child is from the axis of rotation, we can figure all three of these things out. So let's start with the angular speed of the merry-go-round's rotation. We could describe this rate of spinning in terms of revolutions or radians per second. Here, the angular velocity is represented by a lowercase Greek letter, omega. That's the fancy W. We can also give angular velocity as either revolutions per second or radians per second. So we need to remember the conversion factor is 2 pi radians equals 1 revolution. So moving on, let's look at how fast the child's moving. We found an angular speed for the merry-go-round, 0.5 revolutions per second. To change this to tangential velocity, we need to know the distance the child travels in one full revolution. The circumference of a circle is 2 pi r, and the radius here is 1 meter. So the child travels 6.2 meters per revolution. The second line shows the angular velocity multiplied by the conversion factor 6.2 meters per revolution. A quick calculation gives us a velocity of 3.1 meters per second. This is the child's speed or tangential velocity. We say tangential velocity because if the centripetal acceleration suddenly disappeared, the child would continue traveling in a straight line. All right, so here's an interesting question. If the child was on the edge of the merry-go-round, would they be moving at the same rate? And the answer, yes and no. If we're describing the child's motion in terms of the angular speed of the merry-go-round, whether they are sitting at 1 meter or 2 meters, the angular speed is going to be the same, 0.5 revolutions per second. Technically, though, it isn't the child that's rotating, it's the merry-go-round. When we look at tangential velocity, it's different because the radius that the child is from the axis of rotation is twice as much. So whereas we calculated our tangential velocity at radius of 1 meter to be 3.1 meters per second, at 2 meters, it would be 6.2 meters per second. So the radius matters because it makes the circumference bigger. Finally, we can calculate the centripetal acceleration by substituting in the tangential velocity and the radius. When we do that, we get 9.6 meters per second squared.